Thanks, Sam, for that wonderful presentation. So now we will take a step back from essentially even before using these tools for actual decision making. So one of my hypotheses is it's actually a design challenge because there are so many moving parts within themselves, especially when these tools are used in the decision-making process. And not just as an AI, as a technical instrument, but how does we extract public good from it? And that's essentially is the core essence of my talk. And it will have a lot of visual elements to that, specifically building on some of the projects and stuff that we are doing at CHIA. So we hear a lot about AI, responsible AI. There are lots of definitions. There are lots of context around what is responsible to one group may not seem responsible to the other, and it goes around different context around regulation, safety, governance, and even accountability. So there are lots of context around who is going to oversight. Is it an individual? Is it a big firm? Is it a group of organizations who are going to do that? What about different context around privacy, security, governance? EU AI Act is one of those very important act that lays down some of these rules, but again, there are lots of clarity that needs within that context itself. So what we were doing here in Cambridge is essentially trying to look at this problem one step at a time. So there are lots of, I'll start now by one of the big context around what do we mean by public good, and specifically when we talk about AI. And one of the things is essentially, you probably have already heard by now that the AI has potential to solve some of the pressing challenges. I mean, it's true. And there are lots of examples, right, from healthcare, which would include early disease detection, to Sam presented conservation evidence synthesis, to personalized treatments. A lot of our work in Cambridge, especially in the biomed campus, are focused on early detection as well. I specifically work in the climate and sustainability space, so that's also AI is actually helping us to do large-scale modeling. Even the ones that we would usually require supercomputers can now be done in a laptop. So that's one of the real power of compute that we have, and the scale up and scaling down of those processes. In education, so one of the interesting things that I do with my hat as a assistant professor is to teach math to designers, future designers. And that's very interesting because half of my class are visual learners, where half of them are empirical learners. And these kind of tools actually help visualize. So for example, again, from the last talk, when the transformation of 3D space into 2D space, those are some of the hard concepts that these tools really help in the education context for us. And then very specific applications to the public good space is like optimizing traffic flows, improving disaster response. So in the climate itself, there is a lot of context around early warning systems. So how do we design these early warning systems for climate, and specifically by integrating different forms of data in that form. So that do remain one of the very important kind of flows. And I work with the Department of Work and Pension with UK government, and they are also experimenting a lot with universal credit systems and how these tools can actually help unpack the complexities within themselves. But then what are the challenges? So if these tools, in one hand, they look really promising, but again, as I mentioned, this itself goes back to the design challenge. So if these tools are not designed with the exact user specifications in the mind, so there are a lot of challenges and potential of amplification of existing biases. And I think that's one of the big problems here. So the first point is amplification of biases and creation of new form of discriminations. So one really specific example is the use of deep fakes that we often discuss and see in various social media platforms and how they amplify. So one context is misinformation and polarization, but with these tools, they can be really amplified and scaled that has physical impact into themselves. And then there are other elements like, for example, if these tools are actually used for direct decision-making context, which can be policing, which can be something to do with emission reductions or trade flow. Do we know who are making these decisions? Can we open this black box? So they do remain some of the big questions with responsible AI. And at more individual scale, it's the privacy and security risks. So we don't know where our data is ending up. A lot of laws and regulations now are trying to bring that control and transparency to those on our data flow. But as we move towards more digital economy, this remains a real concern. And the bigger impact of those is how public trust is eroded. So again, the link between technology, public trust, and also from where this information is flowing, I think those are very key questions with how are we designing these tools and specifically in the context of responsible AI. So a very generic definition of we all hear about responsible AI, and I mean, in most of the kind of boilerplate definitions would be this: to ensure AI serves humanity's best interest, promote equity, sustainability, and planetary good. But also it has these three big pillars. So one specifically is to align with the law, that's the lawfulness. The second is ethical. A lot of our work is on the context of AI ethics. So how do we align with ethical principles? How do we align with societal values? And they are very context specific and context sensitive. So how do we ensure that? And then one of the more technical challenge is robust. So how do we ensure that existing loopholes or existing areas where errors can be made can be reduced? For example, coding errors or human errors in the software design itself. So is there any way to work on those and correct? So this is essentially how Microsoft is defining the broader context of responsible AI. So there are two distinctive zones that researchers have traditionally worked, and now these are getting closer with this intersection here, where the more context around safe AI or safety AI becoming more important. So for example, in the ethical AI context, there is the context of inclusivity, accountability, and in explainability, so a lot of, work now or even firms that talk about explainable AI. So what do they mean? So they would mean that there is a level of transparency on how these algorithms or essentially the statistical frameworks are leading to a certain outcome, and do we have more understanding of those? So that's more in the explainability, and the intersection is where that's a lot of design thinking is needed or systems thinking, that how do we not compromise reliability and safety as well of these systems together while maintaining all of these ethical and explainability context here. So at CHIA, so CHIA stands for Center for Human Inspired AI. So this is one of the centers in Cambridge. And this is a very unique center because it not only has computer scientists, but anyone who is interested in application of those two various problems. There are many pillars of research here. So I lead the AI for sustainability pillar and essentially try to understand with different environmental, social, and economic challenges and how AI might help in addressing those. So there are four distinctive projects or kind of the bigger like groups that run within this spectrum. So one is from a very business decision-making point of view, which is called Sustainable Innovation Lab. The other one is mine, which is Collective Intelligence and Design. So how do we work with AI and with human intelligence together in a way to co-create and think of these processes as a design challenge. A lot of core machine learning and AI work is done in the weather forecasting and modeling. So we will see a very interesting video after this speaking about how these tools are used in different contexts, right, from global scale weather prediction to city level movements. And then there is Cambridge Center for Carbon Credits, which again talks more in terms of measuring, specifically using geospatial data sets, lots of LiDAR and ground-based scanning data, and how AI as a tool is actually helping in understanding carbon credits or even estimating those across different contexts. So one of the things is like the interaction of climate and urban environment. So this is more of an example here, and specifically when the context becomes more hyperdense urban cities, and especially in global south context.
On Monday, the storm will veer north again and approach Taiwan. There are big uncertainties regarding its path. Different paths will have different levels of impact on.
So just a context over this. So here the main idea is to showcase how tools which support or the computational elements supported by AI is actually helping in prediction or making a more accurate prediction for some of these extreme weather events.
Imagine a world where we can predict the future. Digital twins are virtual models that mirror the real world and let us see the future to better understand the impact of today's actions on tomorrow's world. Meet NVIDIA Earth 2, a digital twin that uses the power of AI, physical simulations, and computer graphics to make weather and climate predictions at a global scale.
So these kind of visualizations which come from like each of these data points which we get through Earth observation, through different sensors. So they represent context like multimodal data, which is different sets of data representing different physical phenomena. But AI in this case is actually helping in threading those or tying them together to come up with interesting visualizations like that. So there are different ways of doing it. There are computational fluid dynamics, which are more in terms of showcasing how wind moves or a cyclone moves around Earth, and then have the ability to move back and forth from that context here.
On Monday, the storm will veer north again and approach Taiwan. There are big uncertainties regarding its path. Different paths will have different levels of impact on Taiwan.
Imagine a world where we can predict the future. Digital twins are virtual models that mirror the real world and let us see the future to better understand the impact of today's actions on tomorrow's world. Meet NVIDIA Earth 2, a digital twin that uses the power of AI, physical simulations, and computer graphics to make weather and climate predictions at a global scale. CoreDiff is NVIDIA's generative AI model that was trained on WRF numerical simulations to generate weather patterns at 12 times higher resolution, from 25 kilometers to 2 kilometers. This is a monumental leap in regional weather prediction, and remarkably, CoreDiff AI does this 1,000 times faster and 3,000 times more energy efficiently than traditional physical simulation methods. Here in Taiwan, the Central Weather Administration is using these models to forecast typhoon landfalls with more precision. But we are not stopping there. The next frontier is hyperlocal forecasting down to tens of meters, where the effects of city infrastructure are taken into account. CoreDiff AI is also being trained using high-resolution data, such as that generated by Palm, a physics model that simulates atmospheric and oceanic boundary layers. When combined with weather simulation wind fields, it can model the airflow around buildings. We expect to predict phenomena such as downwash, where strong winds funnel down to street level, causing damage and affecting pedestrians. NVIDIA Earth 2, an excellent example of a digital twin that fuses.
So, I mean, that's one example where specifically the tools that's developed in lab are in working with NVIDIA and some of these big tech firms to essentially have these use cases. So one of the example was that downscaling factor. So how do you, I mean, it's the data that you need to model Earth, it's already, I mean, it's quite large, but it gets even more complex when you want to downscale it to tens of meters at a city scale. And that's where a lot of these modeling help, and from that AI lens actually help in downscaling those models. And those are the current work that's being done here. And similarly, one of the things is, now one element is you make a model, and then that's fine, but how do we ensure that decision makers who are going to use those models trust these tools? And that's one of our projects that's supported by AI at CAM. So AI at CAM is one of the flagship mission from Cambridge, and their whole goal is to kind of align it with AI for public good. And here we are working with Cambridge City decision makers to better align our models, to better align the expectations of how we bridge this kind of application and trust gap from AI to actual decision-making space. So the project is called Decision Making with AI in Connected Places and Cities. So is it just AI? We use it for traffic optimization, and what will happen if we go beyond that? So how do we look it into our social, economic, and kind of cultural factors in context as well? So again, this is one very nice video that Cambridge made in the same context.
When we're making a plan to shape our city and area for the next 20 years, we want local people to have a say in where they live and work. People are really engaged in this area, and we had over 9,500 comments from our last public consultation. These comments can be about anything from basic utilities, like traffic lights and lampposts, through to some of the unique challenges we face in Cambridge, such as the amount of pedestrians, cyclists and vehicles sharing the same spaces, as well as trying to preserve and protect the special qualities and features that we see in this area.
And I believe going through these representations take around 450 days.
That's right. It takes a team about 450 days to work through all of the comments before we can then move on to the next stage of the process. So we really want to find a better way to summarise all of the comments and speed up the process. We're currently working with the University of Liverpool to develop a bespoke AI language tool that can summarise all of the comments. And we're hoping it could save at least 60% of the time compared to what it does now, so about half a year. Before we developed the tool, we were connected with AI at CAM and you and your team, Kwajo, to understand the ethical considerations around developing such a tool.
And it's very important, rightly so, because first and foremost, you are a local authority working directly with the public, and so that's important. Ethics cannot be ruled out of the picture at all, because previous attempts elsewhere, for instance in San Francisco, where they attempted predictive policing, had to be cancelled because of discriminatory outcomes, and also the sidewalks project in Toronto also faced challenges, significant challenges, and had to be cancelled because of privacy concerns. So really, in order to understand what the AI-based tool can and cannot do in analyzing the representations, it's important to put ethics right at the heart of it.
Yes, that's right. We really want to make sure that what we do is right from the start and is also right for our local area.
This is exactly what our project at AI at CAM is about, ensuring that public value is at the heart of AI use. Together with colleagues at the University of Cambridge and Anglia Ruskin University, our work involves ensuring that potential ethical issues around trust and
So basically, that's one of the use case where city authorities, they receive a lot of comments in a text format, and AI tools, especially natural language processing, can really help in speeding up the process. And that's what we call also as a human in the loop design. So when we are designing these AI tools back in our lab, these comments or these perceptions or perspectives can really help us align the outcomes based on what's the actual need in a very context-specific place. And this is one example where Cambridge has its own specific needs in terms of what an AI tool can be used for its city planning purpose. And that's exactly what we are trying to see, that which areas are generating what context and what kind of comments, and how that can be fed back into different ways of optimizing transport, optimizing pedestrian routes, cycling routes, and et cetera like that. So again, that's the whole take that around. So designing AI for public good is essentially unpacking these layers, multiple layers, that it's not just a computer science problem, or it's not just a statistical problem. It's a very interconnected system design problem where there are different moving parts that needs to be connected for that common goal. And thank you so much.